Hello everyone! Today we're gonna talking about entropy and its physical interpretation. To begin, we have the table of contents composed of Kelvin Planck and Clausius statements, difference between reversible and irreversible process, definition of entropy as a state function, change in entropy in reversible and irreversible process. Example, reversible isothermal expansion of an ideal gas. Calculation of delta S using integrals and tables, and finally combined use of the first and second law of thermodynamics.
Hello, my name is Ana Sedano, and today I will discussing the statement of Kevin Planck and Clausen and the difference between reversible and irreversible process.
According to Kelvin Planck's statement of the second law of thermodynamics, it is impossible to construct a cycling machine that take heat from a single source and transforms in interlink into work to produce another effect. In other words, no thermal machine operating in a cycle can be 100% machine efficient. It always requires to source a different temperature, a hot source from which it extracts heat, and a cool source to which it rejects a quantity of heat. This is why combustion engines, steam turbine, and thermal power station always expel heat into environmental. This rejection of heat is inevitable because, in a cycle process, the entropy of the system returns to zero. In Clausius' statement, we have that heat does not flow spontaneously from a cold object to the hot one. A device such as a refrigerator or a heat pump is needed to achieve this transfer, which required an external energy input. The heat input from the heat source is partly converted into work, and the rest is transferred in the form of heat to a source at a lower temperature than the former. A reversible process is one in which the system and the environmental can return to exactly the same initial state they were in before the process took place if we reverse to the course of the process. An irreversible process is what we encounter in reality almost all the time. The system and its environmental cannot be restored to their original state at the same time. Since this is what happens in nature, it is also called a natural process.
Hello, teacher Liliana. Hello, classmates. I'm Valerie Ramirez, and today I'm going to talk about entropy as a state function.
Definition of entropy as a state function. Entropy, denoted by S, is a thermodynamic state function. It means that the value of entropy depends only on the current state of the system, its temperature, pressure, composition, etc., and not on the path or history the system took to reach that state. Key consequence. The change in entropy between two states, delta S equal S final minus S initial, is always the same, no matter whether the process was reversible or irreversible. To calculate delta S for any process, even irreversible ones, we are allowed to imagine a convenient reversible path between the initial and final states and calculate delta S equal Qt along that reversible path. Because entropy is a state function, we can assign absolute entropy values to substances. Thanks to the third law of thermodynamics, which says that the entropy of a perfect crystal at 0 Kelvin is zero, we can calculate standard entropies S degrees at 25 degrees Celsius and 1 bar by integrating heat capacities from 0 Kelvin to 298 Kelvin plus the entropy change from phase transitions. That's why you see tables with absolute entropies like S degrees H2O liquid equal 69.9 J mole K, S degrees H2O gas equal 188.8 J mole K, etc. In summary, calling entropy a state function is what makes it so powerful. It doesn't matter how messy or irreversible the real process was. The entropy change of the system is always perfectly defined and path independent. This is the fundamental reason why we can use entropy tables and calculate delta S for any real world process, even explosions or free expansions. By the other hand, we have main characteristics. State function versus path function. Unlike path functions such as heat and work, the change in entropy is calculable between state points. Implications for thermodynamics. For a reversible process, the change in entropy of the universe is considered zero, which occurs naturally. The entropy of the universe always increases. Practical application. Entropy is useful for determining the spontaneity of a process. Entropy is a measure of the disorder or dispersion of energy and matter in a system, increasing with a heat or the formation of solutions.
Hello, teacher. My name is Susan Rodriguez, and today I explain entropy variation in a reversible and irreversible process. An example of reversible isothermal expansion of a real gas.
On the side, we'll discuss entropy variation in reversible and irreversible process, and the reversible process where the entropy of the universe remain constant, allowing the system to be in equilibrium at the time, which implies that there is no generation of internal entropy since the system can return to its initial state, which to alternate the environment. Where the entropy variation is present for an solid system, S equals 0. For a non-solid system, S equal integral parents dq rib divide temperature. There, the Q rib is the heat exchange reversible. In the irreversible process, entropy in the universe increases the temperature and pressure present occur, generate international balance. There, the total entropy of the universe system addition environment always increase, and the process cannot be reset without internal change. For an solid system, is a delta of S greater than 0. For a non-solid system, delta of S equal integral parents dq divide temperature. Addition S grain share S grain greater than 0. This is representing the entropy generated internally. On the slide, example of reversible isothermal expansion of a real gas. During the reversible isothermal compression of 3.0 moles of an ideal gas at a temperature of 291 Kelvin, and the pressure changed from 3.0 atm to 5.0 atm. Calculate the work done. It shall be noted that for reversible isothermal process of a gas, the formula work equal nRT, natural logarithm, parents, final volume divided initial volume is used for an ideal gas. With the number of moles and temperature, the formula parents final volume divided initial volume equal parents initial pressure divided final pressure is used. Therefore, the work for an isothermal system can be expressed as a function of pressure gas. Work equal nRT, natural logarithm, parents initial pressure divided final pressure. The operation 3.0 moles multiply 8.134 Kelvin negative 1 multiply mole negative 1 multiply the temperature 291 Kelvin. Parents and the change from the pressure that 3.0 atm to divide 5.0 atm. Um, the word finally is the 3707.6 joules.
Good morning, afternoon, of everything, teacher, depending on when you are viewer this. I will be
Okay.
speak to you
Entropy is a state
today
function
about the
that
use
measures
the
the
integral
degree
in
of
the
disorder
topic.
and the irreversible of process. To understand in the practice, we calculate its variation. Delta is where is a system change state. This can be done through integral is irreversible process or be using thermodynamic tables. First, the general
Resistance.
expression for a reversible process is where it represents delta is entropy change of the system, infinity system amount of heat exchange in the irreversible process, T absolute temperature in Kelvin at which the heat transfers occurs, E for finish, initial and final state. Okay, when the heat absorbed depends of the heat capacity and constant pressure. CP heat capacity and constant pressure. T is initial temperature. The final temperature. Logarithm natural. For real substances, we use it tables thermodynamics. Delta is C over minus C for ice. C entropy evaluates at the initial state from tables. See if entropy evaluates at the final state from tables. The application in environmental engineering entropy variation calculation RK-int was there were treatment plants estimated the energy cost of the heat of evaporation stream, anaerobic digester, analytic terms efficiency in biogas production, water incineration, measuring irreversibility and energy loss, heat recovery system harness residual energy to reduce environmental footprint. Okay, applicated example. Hatching 1 kilogram of water from 25 grados Celsius to understand grados Celsius is equal caloric specific 4,18 kilojoules kilogramos sobre Kelvin. The resulted analysis is the water increased is entropy by 0,92 kilojoules, reflected greater molecular dissolved and high temperature. This value is minimum theoretical entropic change in the reversible process is practice entropy generation with the high
The
due to loss
thermodynamic
and fiction
tables is
for a plant's
calculations
heat
canon